Hello, everyone, and welcome. Thank you all for joining us for today's session. My name is Firas, and I'm the event planner for Microsoft Reactor in Redmond. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our presenter and our audience. We encourage engagement in the chat, but please be mindful of your commentary and please remain professional and on topic. This session is recorded. It will be available through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I'll be sharing the link to our YouTube channel in the chat. I'll also be sharing the link to the Reactor Meetup page and also be sharing the link for our survey as well. Which brings us to our session today. This session will run for approximately 1 hour with time for questions throughout. Our speaker for today is Sam Wronski. He's a regional cloud advocate. I'm now going to pass this along to Sam.
Awesome. Thank you so much. Hello, everybody, and hello, Dog Loves Cat. I like your username. Today we're doing the Reactor Collab. I am Sam. I'm a regional cloud advocate here at Microsoft. My job is to help empower all of you to build awesome things with Microsoft technology. So what we're doing today is kind of taking a look at health checks and how you can build hopefully reliable services in whatever language you're looking at. I'm going to be doing some demos in .NET just because I wanted to check out the .NET health check API, but I've implemented something basically exactly like this in things like Spring Boot and Java and seen other libraries that support these things. So it's not just whatever. It's not just a .NET thing. We're also going to be taking a look at how you can use this in Azure Container Apps, inside of Docker, and inside of Kubernetes. So if you're using any of those, you can use this as a way to kind of add health checks to your service. So it's pretty cool. So the reason we have health checks is, I guess there's a whole bunch of different reasons. I'm just going to pull this over here. This is the .NET documentation for it. But there's a lot here. The reason we have health checks is because we want some automated way to say our app isn't working. You might have gotten an email at some point while you're building something from either a friend or from your boss or from something else that says, hey, production is down. This isn't working. And that's not a great way to find out that things aren't working. Ideally, you want some way to automate this. You want some way so that it's automatic. If something is not working, maybe your database can't be connected to from this specific thing. Or maybe for whatever reason, this node that you got scheduled on in Kubernetes isn't letting you communicate in an effective way with the rest of your services. If that happens, you want to be able to detect that and just restart your service and just say, let's move this somewhere else. Let's not do this. So there's a few different ways you can do this. There are what's called readiness checks. This is more of a Kubernetes thing than maybe a Docker thing. But what this is going to do is actually determine if your service is ready to receive traffic or not. So think of that as a way like when you start, I guess we'll jump over to the Kubernetes documentation here. But Kubernetes has 3 different checks. They have a readiness, liveness, and startup probe. And what these do is detect if something is running or not. So a liveness probe is going to detect, is this thing working? Is it doing okay? A readiness check is going to check if it's ready to receive traffic. So when you just start your app, maybe it needs to build an internal cache or do some initialization or pull some information from files or do something to get started before it wants to start receiving traffic. You can use readiness checks as a way to preempt that and say, hey, we're still getting set up. Don't send things here. Sort of like you open the store and you need to pack the shelves and do all this other stuff to make sure that it's actually working. That's what this is doing. It's giving you a way to do all of that setup stuff. So what is the topic for the day? Today's topic is mostly health and readiness checks. We're going to be mostly looking at how to automate the stability of your apps. I think that's probably the best topic. So yeah, I should kind of briefly talk about that. This is the Reactor Collab. We go into all sorts of different types of things. The kind of point of this show is as I'm learning things, kind of bringing them and sharing them, and we're going to learn a little bit live. So I've done a lot with liveness and readiness probes inside of Kubernetes. I have done absolutely nothing with Docker health checks, which is what this is. Don't know what this is, don't know how to get this working. So we're going to try that. And then the other thing, if we have time, is Azure Container Apps also support Kubernetes-based health and readiness checks. So we could also check those out. And then I'm still learning the health checks in ASP.NET Core. There's a cool way to inject health checks directly into your services. So we're going to kind of walk through how to implement those too. So if you're using ASP.NET, this will demo how to do that. If anybody is using like Spring Boot or something, or Flask in Python, let me know, and I think I can probably just pull up some information on that quick. But I don't have anything prepared there. So anyway, that's sort of generally the idea here. Just kind of quickly talking about what these things are. We already kind of covered it in that little talk. But the intention of this is if something fails, we want this to be an automatic process to recover from that. We do not want to have to go and wake somebody up at 2 a.m. because our service is no longer receiving traffic and we just need them to go and restart a pod in Kubernetes or go and turn the server off and back on again. Because a lot of the time, that's all that is needed. Sometimes your process just gets stuck and it doesn't respond properly to tasks or something, and you just need it to not do that. And so the way to do that is just restart it, turn it off and turn it back on again. And that's basically what this facilitates. It gives you a way to say, what does my service need to do to prove that it's okay? And then how often do I want to check that? And how do I want to validate that that's actually happening? And then if that doesn't happen, how do I want to handle it? In most cases, what that's going to turn into is just rescheduling your thing. So on Kubernetes, for example, that would mean your pod is going to scale down and gets rescheduled somewhere else, typically on another node, which is a handy thing. So if a node, for example, is not behaving, if you're on some sort of self-hosted Kubernetes instance, for example, and your node is not doing what you want for any number of reasons, there can be a number of reasons that happens. If that does happen, this can get you off of that without you having to worry too much about it. It should just be an automatic thing, and then you'll notice eventually nothing's getting scheduled to this node because it's all getting pushed off of it. So that's all of that. We're going to take a kind of a quick look and kind of slowly implement things. I'm not going to do too much about how to implement health checks. Unfortunately, it's kind of a specific thing. So I'm focusing a lot more about why we do this and how to do this, rather than here is the exact implementation that I think you should use, because it's going to depend on your app. And especially if you're relying on microservices, every single one of those is probably going to be implemented differently. The way I've done it in the past is just make sure, can I communicate with all of my dependencies? If you have a microservice thing, that might be a database, that might be another microservice that you need to make sure that you can ping. And so that's all your health check is can I communicate with all this other stuff that I need to do my job? And if it's no, then you flag that service and say, hey, this is having trouble communicating, and hopefully eventually it will get rescheduled. Typically, a single failure will not reschedule your job. So what that means is if like one request ends up timing out for some reason, that doesn't mean the service is going to just scale down and go away. You can configure that so it's a little bit less like that. That can be a little bit strict and cause things to maybe be descheduled when you don't really want that to happen. Maybe something else happened. There was some network thing. And so rescheduling it is going to take longer and do other things. So maybe you don't want to do that. Anyway, let's take a look at what implementing this in .NET looks like. And then we'll kind of talk a little bit more about how that is, because then we'll have an example. So let's pull up this. Apologies if things are weird. My computer crashed 2 weeks ago. And so like Docker just got working less than an hour ago. So things are a little bit fragile. So we'll see how this goes. But for this, let's do a .NET new web API and create sample health check example, I guess. Sure. And then let's go and open that. So code-n. If you aren't familiar, code-n, if you install Visual Studio Code, it adds tools to your command line. And if it hasn't, there's a thing to do that for you. But it's going to add these things to your command line that are going to let you open Visual Studio Code. So -n is saying open a new version of Visual Studio Code with this new directory. And so I'm passing in the new directory that I just created. And so by doing that, we're going to get a new Visual Studio Code instance in that directory. And so that way we can just start working from there. You don't have to go and open it and then click open file or whatever. It can do all of that. There's also other really cool things you can do with that, with like opening diff files and things like that. If you want to integrate Git or some other source control thing directly into that and use this as a diffing thing, it's fun. The other fun thing with that, if you use -r, it will reuse your thing. So just as a quick example, but if you're in the integrated terminal, for example, and you want to open up a different folder from this, so let's say I want to go up, I can just do this. So -r is reuse the current existing version of Visual Studio Code, and that would go up one directory and open that in Visual Studio Code in this window instead. So that's how to do that. If you don't see those in your terminal, it's like add to shell or add to path, something. There's a command up here. I don't know what it is. But anyway, it's there. So anyway, that's a little bit off topic, but it's super cool. So what we have is our basic weather forecasting API. We are not going to do anything with this. That's not really why we're here. There's a few things we do need to do though. So in order to get this to all work, we need to add the health check API. So the way this works is you do services.add health checks. That's going to go and actually add the health checking service. And then that's pretty much all you need. The only other thing we need is actually map a health check endpoint here. So we're going to map health. I think that's the name. And then I think the default is /health_z. I believe the Z is used so that it doesn't conflict with other REST things. And where map health checks. There we go. And that's that. So we've created our new health checking service. It doesn't do anything interesting, but it works. That's all we need to get this to work. So if we .NET run this now, we should be able to see our app get started up. And we now have this new endpoint that's going to say healthy or unhealthy or degraded. Those are the three states that we can get in this version of a health checking API. So let's just grab a URL and then we'll pull this over here. That's not right. There we go. So this is Nightingale. It's a API thing. If you're familiar with Postman, same thing. It just lets you make calls against websites. So we're just going to send a request over to LC, and I get a 404. That's not what I expected. There we go. Okay, it worked. I don't know what I did, but it works now. So now we get healthy. So our app is good. This is a good response. So we're going to get a 200 response from the URL, and we're going to get a healthy response. So that's telling us that every health check that we don't have any, is passing, and this app is healthy. So what we want to do now is actually add a health check. So there's a really cool interface for this. So if we go and add that, let's do just a sample health check. And go from there. I don't actually know any of this, so let's there's a template in the doc. So there's a link in the chat to a doc. If you're looking for the template for how to do this, it's there. We're just gonna go and wing it and see what happens. I believe it's health check. There we go. Found it. All right. So that creates a health check that has one method. It's this one. And so most of this doesn't really matter. The interesting thing is that what it returns is a health check result. And that health check result is going to have three different things. It's going to have two different things. It's going to have the status, and it's going to have a message about what that status is. So let's make our service fail. So let's return a new health check result. That health check result is going to have a health status and a string to describe what is happening. All of that is optional. You can also include exceptions and things. But for now, we're just going to add a health check status. So health status. We're going to say it's unhealthy. And we're just going to say testing. There we go. So what we've done is make this not work. What have I done? Let's make that async. There we go. So that fixes that. And now we have this health check result that's going to return an unhealthy result. So our service still hasn't changed. Because we haven't actually assigned this to it. So there's a few cool things that are happening because of this. One, we have different versions of a health status. Typically, I was talking about how when we have health checks, we typically want to see if it's healthy or unhealthy to see if we need to reschedule the job or something. There's also degraded status. So if performance is below what you expect, maybe messages are taking hundreds or thousands of milliseconds to arrive instead of just a few milliseconds, that might be a degraded status. Again, it's going to depend on what you're building. If you're interacting with databases, that's very different than interacting with other services and so on. But you can use this as a way to kind of gauge the severity of these different things. And you can actually turn that into different health checks. So you can actually say, this should fail. If there's any degradation in our service, we want our services to fail. The downside of that is if you make things fail too much, they're always going to be getting rescheduled. And that's not good for your service because it takes time to schedule and create a new thing. So if you're constantly scaling up a new app and then a minute later realizing, oh no, it's unhealthy, it's too slow, and then scaling it back down and scheduling it somewhere else and then doing the same thing a minute later, that's not good. So you'll want to tweak these so that it's reasonable, but also able to detect if something isn't working. If you're getting a large number of failures in your requests, that might be an indication that something else is not good. So figuring out how to do that is kind of its own little science, but this is sort of the introduction. Talk too much about that, but we have this. So this gives us a way to say the service is unhealthy. So let's go and add this to our health checks. So we have add health checks. We added that service. Now let's add a check. And we're going to add the sample health check. And then this has a name attached to it so that you can actually know the name of the health check. The reason for this is you can actually have multiple health checks with the same name. So cool thing with that is, let's say you want to have something that validates database connections or service connections like we talked about. You can implement a health check that tests if a service is available that isn't specifically pinging for your app or for something else. It could be something that you could share more broadly. And then you can reuse that health check in every one of your services and give it parameters to say, it should be able to talk to this service and be able to do this with this database. Those kind of things can be done with parameters instead of doing that. And then you can just give them names to distinguish them instead of trying to recreate a new class every time you want a new health check, because that can just be a lot. So this gets around that. So by doing this, we should now have a health check that we can actually run, and our service should no longer work. The important thing is this doesn't make my app fail. Every other part of the service is still going to work. So if I wanted to go to this website, I should still be able to do that. I'll just copy that for later. But if I ping this now, it's unhealthy. If I go to my service, Well, that's maybe not a good example then, is it? Why did that happen? Oh, it's a web API. There is no. Okay, that's my bad. So this should be at. Let me see. Controllers. Weather forecast. All right. Let's do that instead. Something that actually works. So we have this that says it's unhealthy. But if we actually go to our thing and request it, we should still be able to pull the API. It's not saying, oh, don't let the API work for any reason. This is just another API that tracks the status. So there's a bunch of other things you can do here. I'm talking a bit much about the .NET APIs, but there's a lot here. So we've kind of implemented this as a way to fail the service. The other things you can do is down here, you can actually set up filters. So we have the health check options. Ignore that, that's long. But there's a bunch of different things in here that we can do. So for example, what was the one I was looking at? The allow caching results. This means that your results aren't cached. They shouldn't be cached on the site. But this is going to tell back. Also, I should call this out. We got our message as a failure in our logs automatically. So because our health check failed, we get a log message that's going to describe what happened. So before I get too lost in this, let's go and talk a little bit about what this is. What this says is health check sample with status unhealthy completed after 1.4 milliseconds with message testing. So there's a bunch of keywords in there. So where are those coming from? In this case, testing is the description that we gave this message. So if you're using something to describe what's happening, that's going to end up right at the end of your message and saying, here's why this didn't work. So if you make that useful instead of testing, you're going to get more useful information. Ideally, something that's actually helpful, because a lot of the time when things aren't going great, it's not usually like noon or 1 o'clock. It's usually later in the evening or on a weekend or something when you're doing something else and distracted. And so you want something that's going to actually kind of help you figure out, why didn't this work? Typically, this will help you out and help find things, but one failure isn't necessarily going to indicate this should restart. And so one of the cases that I've run into in the past has been you have sort of a flaky health test. And so what a flaky result means is something that is true and false, sort of indeterminately. It can fail and then succeed and then fail and then fail and then succeed and appear somewhat fine, but it causes a bunch of noise in your results. And when that's happening, it can be really hard to actually like reach your threshold for failing a health test, because you might be able to get a few messages through to something else. And typically services are going to expect 3 or 5 or so failures before rescheduling your thing. And so if you have something that's flaky and failing on and off, that might not happen. It might just be, okay, this is kind of fine, but we have like 30% of our messages are failing. How do you detect that? And so seeing a whole bunch of these logs can help indicate that. So you can help track that. So the other thing we're seeing here is sample. Sample is coming from the name of the service we added. So all of your checks get a name attached to them. In this case, we gave it sample just to say it's a sample, but that's the name of the health check. So if you're naming it something useful, people are going to be able to find that. And then the other status is unhealthy. That's what we reported. And so that caused a failure. If we swap this over to a degraded state, well, before I do that, just to double check, let's hit that. So we get unhealthy here, but we also get a 503. So we get a server error, which is different than a 200. So this is actually going to return an error result in our HTTP result. So you actually see an error. It's not just you have to parse this message because that's a little bit much. You can actually rely on the HTTP code. So if the response is a failure, it's a failure. And then if we switch to degraded, I don't actually know what that is. So let's go and find out. But yeah, you can see we get another message, slightly different time, but everything else is the same. So every time we've hit that, we've kind of seen that this is failing. If we go and rerun this now, we have .NET run. That's going to go and start a new service. And now it should be in a degraded state. So now it's degraded. This is returning a 200 because our health check is configured that only unhealthy states is a failure state. So what you can do is you can kind of change this. In this case, we're still seeing that the service is degraded. So the worst case of all of our health checks is degraded, but we're still fine. So our service is still saying it's okay. It's in a 200 state. Things can continue running, but it's degraded. There might be some issues. And we'll see a log message too. So in this case, we get a warning that we're in a degraded state. So you can kind of track things that way. But if we want to turn this into a failure, I don't know how to do that. So let's go and find out. I think it's why I created this mess. So let's go and figure that out. If we go into our browser here, we look at health checks. There should be a health check options. I think this is where I wanted to go. Yeah, so result status codes, you can actually change what these are. I think there's an even another way too. Failure status degraded. There we go. So this is actually when we're adding this. You can say specific checks should have a failure status. So let's look at both of those. So this is global. This is going to affect the endpoint. If I want to customize just this check, I think I can add a failure status here and say this fails if it's in a degraded or unhealthy state. So it's kind of a step thing. So let's see if that works. I haven't tried this, so who knows? But what I'm expecting now is that this actually triggers a failure. So we'll still see degraded in our message that comes back, but we should now see a 503, or we should see an error come back as a HTTP status. So let's check that. Nope, still works. So that didn't happen. I don't know. Cool. Well, I tried. Let's go and try this. So this one I'm more familiar with. So we can actually change the result codes for this, and that might be why I'm seeing this. Is you might be seeing different sort of both of those happening. I'm not entirely sure about that other one. But this, we can actually take the result codes and specify what the HTTP status is for different results inside of our thing. So if I want to make this into a service unavailable, 503, then I can just change that. And so you can actually send back all sorts of different things. Maybe we want it to be, is this still a thing? Teapot. Yep. All right. So maybe if it's in a degraded state, our service magically becomes a teapot. So we can do that. And let's actually see if this works. So 418 is I'm a teapot. Probably don't ship a service that returns a 418, but it's there if you want something that's a little bit more fun. So let's go and request this. And now we get a 418 response. It's really hard to see, unfortunately, because I can't zoom in on this, but 418, you're a teapot. So we get different status codes depending on that, so you can actually customize this. So if you want degraded statuses to cause health check failures, this is how you do that. I think this is mostly all I want to talk about on the .NET side. There might be a few other things that we can come back to, but that mostly covers all the main points. The only other interesting thing that we probably want to talk about is I mentioned passing arguments, and I kind of skipped over that. But there's a bunch of things here. You can pass arguments into your health check. Type activated. I think it might need to be a type activated thing. But what that does, I'm not going to write that just because it's here. But what using a type activated argument thing is going to do, weird words, but it's going to pass in your arguments to the constructor of the object you're trying to create. So if you're trying to pass in, this should talk to this microservice, that's how you do that. You pass that in as an argument when you're assigning the service. So just like we had the failure status that I added that didn't do anything that I could figure out, we would add arguments here. So args, oops. And then you just start adding like a tuple of arguments here. And that would give you a way to kind of send these new messages and create potentially duplicates of the same health check with different results. So if we have time, we'll come back to that because then we can actually add an argument. But I quickly want to talk a little bit about how these are actually used, because so far we've just created an endpoint, and that's that's cool, but it's not actually that interesting, I guess. So far, everything you could have done, you probably could have done with just a web API thing. You could have just made your own path, implemented your own controller, and done it all yourself. This is just a lot of helpers to make that easier. This becomes powerful when you actually start pairing this with all of your orchestration frameworks. So when we talk about orchestration, that's the thing that is handling, scheduling, and deploying your thing to specific places. So that might be Docker, it might be Kubernetes, it might be some Azure service like Azure Kubernetes service or Azure Container Apps or something like that. Depending on what it is, it's going to want to deploy your service in a specific way. It can check if it's healthy. They all do this in slightly different ways. Conveniently, because Azure Container Apps is using Kubernetes as sort of its backend, the definitions for a Kubernetes check of liveness and healthiness is the same as what you do in Azure Container Apps. That's identical, but it is different in Docker. So that's not something I've used, but I'm going to quickly talk about how to do this because it's interesting. So what a health check does in Docker is run a command. It can be any command. So unlike where in ASP.NET, when we were creating a REST endpoint to do this, in Docker, that isn't necessarily the case. So if you're creating a container, you can write a health check that checks, does this file exist? Is this environment variable set? Those are all valid things you could do because it's just a command. So what this ends up looking like is I'm going to go and copy my little test environment, all of this, and we're going to bring it over here. Yep. And so what this is doing, I'm just going to delete that, is create our app. So this is slightly modified. Let's see here. Health check example. There we go. So that should match. And now what this is doing is creating a .NET container. So it has our build layers, and then it has our final deployment layer. So inside of that final layer, we can add a health check endpoint and do health check command that's going to actually run on some interval and for some other arguments. So what this is going to do, it's going to figure out how to do all of that. So we can have an interval. Let me make that slightly bigger and then get lost. Let's see here, health check. So we have an interval that's going to define how frequently should this run. We have a timeout that's going to define how long should this run before it's considered a failure. So if you run this command and it never returns, that's probably not great. So you're going to want some sort of failure state. The default for those is both 30 seconds. The other thing you can have is a start period. So you can have a period of time before it starts checking this. So if you have a container that starts up really slowly, and then you're doing, let's say you're, in this case, the timeout and interval is 30 seconds. So if you run this and your start period is 0 and your container doesn't start immediately, let's say there's a bunch of initialization things. So like I run a Minecraft server in Docker. That takes a while because it actually downloads the entire Minecraft server, spins everything up, and creates the world for you. That takes minutes to start. And so in this case, we have 3 retries and an interval of 30 seconds. So it's going to fail before it ever creates the image. It's never going to stand up. And so this gives us a way to kind of preempt that and give ourselves a relatively sane start period that kind of anticipates some of that, because you probably know your services better than these defaults. And then we have the number of retries. So if it exceeds the number of retries, if it's unhealthy for that number of retries, so what that means is that your command argument returned a non-zero result 3 times in a row. If that happens, it's going to restart your container. So this is how you would do this inside of a container. You can do this for most containers. It should work. I've been just tinkering with this, so I haven't done too much with that. So what that would end up looking like is, I think, let's just grab a timeout. And so I think we can just grab this and, whoa, that's not right. Let's do interval equals, say, 5 seconds. And then we're going to have it run a command to go and curl our localhost 80, I believe, is the port that we run this on inside of our container. Why doesn't it like this? Hold on, let me double check. Health check, interval equals. Okay, that's fine. Or exit. So the or exit one is just going to exit it out afterwards. And then enter, I spelled that wrong. That's why. Cool. All right. So what this is going to do is every 5 seconds, it's going to ping our endpoint and ask if it's healthy or not. And then we should actually be able to see that in Docker PS. So if we do, yes, I don't have anything running here. But if I build this now, I'm going to give it a name, and I've completely forgot how to tag things. You tag sample health check. Go. It needs a path. So while that builds, what it's going to do is build everything like normal, but when it's running, it's going to actually end up executing that health check. And then instead of just seeing if our thing is up or not, we should see other things. I think that worked. Oh, I've already downloaded everything. So that's why it was faster. So Docker run, and if I run this, you get attached there, and then we now have this. So on port 80, we're going to see this. Failed to determine the HTTP port for redirection. Interesting. Anyway, let's go and look at this. So Docker PS now, our service should be failing, and it's not. Why not? That's not good. Interesting. Okay. That's not what I expected, but okay. Cool. I guess it's how did I fix this? No. Degraded, and then inside the program, that's still, I'm a teapot. Oh, I know what's going on. That this isn't going to work. That's why. So I didn't do this right. So we're going to quickly stop this. If I could type, there we go. So what I forgot to do we're curling this inside of our Docker thing. Curl doesn't fail. It doesn't return a failure state. It doesn't return a non-zero result if this happens. So we're requesting this and everything is fine because we're just getting the result back. And that's not what we want. What we do want is, I've already done this. I'm just going to quickly, is -- fail. There we go. So I'm going to change that. Building it should be pretty quick because we should only need to redo those last 4 layers. The one thing I don't know about all of this is where in your build that health check should end up inside of what layer. I don't know if you want it near the top or near the bottom. Typically, when you're working with Docker, you want things that change the least at the top of your Docker file. So you want that at the highest layer. That's why we separate things like our .NET Restore from our .NET Publish, because we actually want to, the number of times your dependencies are going to change is much lower than the number of times your code is going to change. And so if a layer hasn't changed inside of Docker, and the way Docker builds is it goes down your layers. So each of these lines is a layer. If nothing has changed, if the result would be the same, it's not going to rerun that. It's just going to reuse the cached version, which is why the first time you build a Docker container, it's going to go really slowly because it has to redo everything. But then if you just change like the last thing, so if I just change code, it just has to work with this last bit. So that's the difference. So we should be able to run this now. I don't know why I gave it a tag and then I'm not using it. What did I call it? This sample health check. Sure. So if we run this now, hopefully, we should start seeing things. Docker. Yes, hopefully. Healthy. So it's still starting. You can see it's in the starting state. Now we can actually start seeing our health checks show up inside of our Docker PS. And now it's unhealthy because we've queried our service and whatever query we used did not work. So that's what's going on here. And that gets appended to the status of your pod. So there's a way for you to actually check that. So that's that. That's Docker's stuff. I'm by no means an expert on the Docker side of things. That's typically not what I've used. I've mostly focused on Kubernetes stuff. So readiness and liveness probes have been what I've used mostly. So that's what we're going to look at next. So let's just stop this quick. Laughing Tesla. There we go. Cool. So that's Docker. Let's jump over to Kubernetes. Kubernetes introduces an additional thing, which we haven't covered yet, which is readiness probes. So readiness probes are a way for you to actually detect if something is ready to receive services. So previously I talked about like if you have something that's caching and you want to build a cache locally inside of memory or something, that would be something you would want to check before starting to field responses. If you need to build maybe I don't know what you need to do, but if something needs to happen before your service is ready to start doing things, like we're just returning a static response right now, that's fine. But that's not how all apps work. Some apps need some initialization to happen. I mentioned my Minecraft server needs to actually initialize the entire world before it's ready for people to start going to it. So the reason that's important is because once a pod reports it's ready in Kubernetes, it's going to get rescheduled. So let's say you're trying to scale up and scale down to the next version inside of Kubernetes. If you don't have a readiness check there, what can end up happening is you can say, okay, roll out this new version, and it will just do that. And your new version will spin up. And then all of its readiness checks may fail, but you didn't actually have them specified as a check. So the new version doesn't work but you already saw that they were up, so it scaled down your previous versions. So now your app is entirely down because your app didn't have that check. What this readiness does is give you a way to prevent that. It allows you to say, we need to be able to communicate with these services and validate that everything is good before you send me any traffic. So I need to be able to make sure I can communicate with this database and send this message here. And if I can do that, great, send me stuff. But if that isn't working, don't. because if you say you can, then it's going to think that you're fine. And then all the things that are kind of waiting for that to happen. The way Kubernetes kind of balances things is you say, I need 5 replicas. You need 5 copies of something. And that isn't always going to happen if you are updating something. So the way it will cascade a deploy and say you have version 2 is currently out in production and is working great. And then you roll out version 3. And so version 3 stands up in your cluster and then says, okay, we're good. Everything's started. Our containers initialize, basically. And so version 2 just goes away because version 3 is there. So why do we need version 2? But version 3 can't receive any requests. So version 3 just doesn't work. But you've already lost version 2. So now if somebody sends requests to your service, what happens? It doesn't work. And so if you have that readiness check, the reason it's there is to prevent that from happening. Your message will come in and still get routed to version 2 until version 3 is ready. So even if it's deployed and it's not in a ready state, it will just sit there. So that's why that's there. Kubernetes calls them liveness. And what this is the same thing. So just like we were doing with Docker, where we're running a command. So in this case, they're using cat and reading a file to see if it's healthy. So if the file exists, everything's good. If the file gets deleted or something and cat fails, then your service isn't healthy. And that's all this is doing, is just checking the probe or checking your container and saying, is the service okay? Can it function? If the answer is true, then it's good. And most of the arguments end up being the same here too. So you'll see there's an initial delay and then a period of seconds. You can actually send this. Let me made it bigger. So the period of seconds is the same thing. So in our Docker file, we had an interval of 5 seconds. That's the same as this period of seconds, this 5 seconds here. So it's saying wait 5 seconds and then request again. You probably do not, there's a bunch of different, I guess, guesses that you have to make in order to figure out how this is working. I won't call them guesses, actually. It's probably, you'll have to figure it out because there isn't a good answer for how these should be configured. 5 seconds might be good. But if you configure this too low, then what's going to end up happening is you're going to be sending lots of requests to this thing. And usually I found that they tend to ping lots of other things to make sure everything's working. If you don't want that happening constantly, maybe don't do that. But also if you delay this too much, then the latency of figuring out things aren't working is going to increase, which doesn't sound like a lot, but if you're getting hundreds of messages a second, if your service is down for a minute, you just lost 6,000 messages, something like that. You lost a lot of messages. And so reacting to things really quickly is actually kind of important. So figuring out what makes sense is good. I think 5 seconds is probably fine. It shouldn't be enough that is going to do like a denial of service against your container or something, but it will be enough to actually quickly respond if something isn't going right. And yeah, I think that's mostly it. Using cat, I guess, is a way. A lot of the times I've seen people just query their health endpoints. So we just created this thing that says, is this healthy or not? That's typically where you would ping. You can run other just normal Linux commands. So if you want to validate, for example, are the secrets there? Typically, I would put those into a health checker. So inside of our health check implementation, where'd I put it? There it is. We would go out and do like environment dot exists. I don't even know the name of it. I've only done this in Java, but you would check if the environment variable exists, and if it does, then you're good, and you know your secret is there, or however you're getting your secrets. Maybe you're mounting a file, however that works. But you can use that to kind of check, because a lot of the time you'll need that, for example, to validate with your database, and then you can also validate that actual database connection. So however you want to do that, it's kind of up to you. But there's probably, you probably already know what your app needs to do. That's something that I think you kind of figure out as you work on it. What does this do, and what does it need to talk to do that? And so once you know that question, you can actually kind of figure out, okay, this service is going to go and check the number of apples sitting on my shelf. And so what does it need to do? It needs to be able to access my shelf in order to be able to do that. And so it's going to go and see if it can. And if it can't, for whatever reason, maybe the door is locked, then that's not going to work. That was a weird analogy, but that's sort of how all of these things are kind of designed to work. What else? Oh, now that we're back here, let's quickly look at a few other things you can do with this API, and then we'll kind of go from there. I think that's sort of everything. If you are using Azure Container Apps, it is the same thing. So if you've implemented them in Azure or Kubernetes, and you want to bring them into Azure Container Apps, that it should just translate. And that should work in both directions. So the way this works is you just end up with your YAML. It's configured in a similar way. I think the probes are even the same. No, okay, so the YAML syntax is slightly different, but the actual configuration of them is the same. So that's how that works. So before I end this, there's a few other things you can do here. You might not want your health check publicly available. So you can actually limit that to who is going there. So this gives you some examples of, for example, requiring somebody to be on a specific host in order to do that. So in this case, let's do that. let's make it so only I can invoke this health check. So if I want to do that, sure, we'll keep that. So map health check, and then we just do that require host of, we don't want Contoso. Actually, let's leave that, because this will show what happens if I don't have access. So .NET run, just to quickly run it. And so what we're saying is you can only access this from a specific host. So we're expecting only requests coming from the Contoso domain to be able to access our service. So, and that will only work on the health endpoint. That won't affect everything else. So in this case, we were normally getting it degraded. Now we get a 404, access denied. So we can't get there anymore because we're not on that domain. But if we want to make it so, for example, only we can test it, we can go and configure that to be localhost, for example, and say requests need to come from the localhost. This probably isn't something you want in prod, but if you're trying to test this for like a development purpose, this should work. And so it should start up and then let us actually request this. And now we get our degraded status again. So this gives you a way to kind of request those things and get some feedback back about if it's working or not working, or somewhat working, I guess. So that's all of that. Is there anything else? I think that's mostly it. Has anybody tried this? Has anybody like set up health checks on their services before? I probably should have asked that way sooner. But if you have, I'd be really curious about what you're using them for, or if you've been thinking about them. This was something that I've kind of struggled with. So it's always interesting because there's always the delivering features versus delivering like stable products and addressing technical debt. This tends to fall more into that technical debt aspect and stability side. And so it can be hard to get this prioritized. So one of the cool things with having an API like this that makes it a little bit easier is it's something that you use more accessible. It's something that you can actually just implement really quickly and implement in stages. You don't have to go and implement all of your health checks right away. You can implement just one and say, does this environment variable exist? Am I able to send this REST request? And if the answer is yes, then great. And then you can actually abstract that out and scale it up and go somewhere else. So final thing before we do all of this, let's see. Let's go and figure out how to do this. We want arguments. Where was it? Options. I've gotten lost. Oh no. There you go. All right, perfect. What this lets you do is send arguments into your health check. So that's what we're going to do, is send some arguments. So let's tell it what status to have, because our thing is just returning a status. So let's do that. I'm going to just say arguments. It doesn't have arguments on this, so let's type activated check. That args is something. And then this will be a health check status. Is that the status code? Nope. Health status. There we go. Health status, and we will say unhealthy. And I think this needs a name. Pretty sure. I don't think I'm doing that right. So let me go and figure out where that was, because there's an example somewhere. Just going to find it. Type activated. There we go. So type activated, we have args, new object. Okay, that's what I was missing. Cool. New object. Doesn't implement IEnumerable. Interesting. Okay. Oh, that's why. This needs to be an array. That makes a lot of sense. There we go. We have our new type argument. We're just going to use one for this, but you can actually stack multiple of these. So these are going to be passed into the constructor in the order that they're provided in. So in this case, we have a health status that I want as a private read-only health status, say status, and then I want a public sample health check. Cool. And so now we have a constructor here, and instead of this, we can return our status. And so what this is going to do now is now read in that argument, hopefully. I've never done this before, so we'll see what happens. But we should now have an unhealthy object. So if I go and rerun this, do a .NET run, should start up. And then I can request here. And now we get our unhealthy check. And just to prove that that's working and it's not something else happening, we should be able to change this now to healthy. And this should work. So this is kind of a toy example. This is intended as an example, but this is kind of a way of showing that you can actually pass arguments into this. If you want to say pass in your database string, so you can connect to your database, or something else, so you can reuse these same health checks multiple times. This gives you a way to do that. In this case, we're just passing in the health check, but you can actually implement this to do something else because it's just a function. It can do any of the logic you want. But yeah, that's all the time I have for this. Hopefully this was interesting. This is sort of something that I really push for in the projects that I've worked on. It makes everybody's job so much nicer if you don't get woken up at night because your service is down and you just need to restart something. That's not fun. So having these be effective and useful gives you a way to kind of avoid some of that and just allows the infrastructure to kind of handle those for you in a usually pretty smooth process. So hopefully we kind of covered enough to get you started. If you do get started and start trying it out, let us know. And if you need more resources, there should be a few in the chat that you can check out. Otherwise, there is a survey that we kind of ask for feedback on. So if this was something cool, this was something that you wanted to learn from, if you could fill out that survey and give us a little feedback, that would be great. Or if it's not something you want and you don't want to see it again, let us know there too. But yeah, that's it. Thanks so much, everybody. And yeah.
Thanks again, Sam. I would just like to thank everyone for joining. And as Sam mentioned, if you want to know more about this, we dropped the AKA resources link at the chat. And also, please, if you have some time, we would really like to know what you think of this event. Please use the AKA also link for the Reactor survey and use the code 16411. Thank you so much.
Thanks, everyone.